this class. Today I am continuing the chapter electricity of the subject science and technology of class 9, and this is last part 6 of the chapter electricity. We had divided the electricity into 6 parts and this is last part. And today I am going to focus on heating effect of current, electric power and electricity consumption in household circuit. Okay, but before starting all this, at first we have to understand the effects of current. There is not only heating effect of current, there are other effects of current also. That's why what are the effects of current I am going to tell you. Look at this. First, heating effect of current. Second, lighting effect of current. Third, chemical effect of current and magnetic effect of current. There are four basic types of basic types of effect of current: heating effect, lighting effect, chemical effect and magnetic effect. But number 2, 3 and 4, lighting, chemical and magnetic effect of current, is not taken in the syllabus, not given in the book also. That's why we'll focus on heating effect only, but at least we have to know what they are. That's why I'm saying some important information about this. What is lighting effect of current? The conversion of electrical energy into light energy by an appliance is called lighting effect of current. It's very easy. When we switch on the circuit and if there is bulb in the circuit, then that bulb converts electrical energy into light energy. This is lighting effect. Chemical effect, what is it? Actually, chemical effect means when electric current is passed through a solution, then the components of the solution, I mean to say the compound contained in the solution, dissociates and the chemical change takes place. And this process is called chemical effect of current. Chemical effect is the process in which the compound contained in the solution is dissociated by the passage of current through that solution. Just for example, if current is passed through sodium chloride solution, then sodium ion and chloride ion dissociate with each other. Not only the solution, if we pass current through acidulated water, what it means? Acidified water. If few drops of acid is added in water, then it is called acidulated water. If current is passed through acidulated water, then water dissociate into hydrogen and oxygen gas. This chemical change is brought by current. That's why this is called chemical effect of current. Now, what is magnetic effect? This is very simple. The conversion of electrical energy into magnetic energy is called magnetic effect of current. It is taught in lower classes also. When a nail is placed inside the solenoid and current is made to flow through the solenoid, then the nail gains magnetic energy. This is the conversion of electrical energy into magnetic energy. This way we can understand what exactly is lighting effect, chemical effect and magnetic effect, but in detail we are entering into heating effect. Okay, now I want to show you some devices. Look at this. This is electric heater. You know this. I think you have seen this. Maybe this is in your house also. This is another heater, and the first one is used to cook the food, but the second one is used to make the room warm or to get heat energy in the cold season to make our body warm. And the third, this is used to boil water. This is water heater. And another, this is normally called rod in our daily life, but this is immersion heater. This part is immersed into the water kept in bucket and water is boiled. And this is electric iron, and this is used in pressing the cloth. I mean to say all these devices are called heating instrument, and all of them converts electrical energy into heat energy. And this effect produced by these appliances is called heating effect of current. Now, exactly how can we define heating effect of current? This way. The conversion of electrical energy into heat energy by the obstruction of flow of current is called heating effect of current. Look at this. Conversion of electrical energy into heat energy. How? By obstructing the flow of current. This is called heating effect of current. I want to describe a little detail with the help of this short animated file. I mean to say this video clip. In this clip, what is shown, this is a long wire, and in this wire electrons are flowing. Flow of electron is flow of current. Electrons are flowing from one end to another end, and during its flow it has kinetic energy because it is in motion, and when it flows then it collides with the atom, and a little amount of kinetic energy will be lost by these flowing electrons, and this lost energy will be taken up by the atoms of the conductor. And when atoms take the kinetic energy, they begin to vibrate more rapidly and heat energy produces, because the energy produced in a body due to the vibration of its atom or molecule is called heat energy. This is actually principle of heating effect of current. I want to tell you a little shortly. Listen, this much is very enough in this stage. Flow of current in a conductor is flow of electrons. When electron is made to flow through a conductor, then they have kinetic energy. While flowing, they collide with the atoms and they lost certain amount of kinetic energy, which will be taken up by the atoms of the conductor, and atoms begin to vibrate more rapidly and heat energy produces, because heat is the form of energy which produces in a body due to the vibration of its atom or molecule. This is the principle of heating effect of current. But the amount of heat energy produced in this conductor depends upon current. More the current, more the heat energy. Instead of 1 ampere, if 2 ampere current is passed, then the amount of heat energy produced will be more. And this depends upon resistance of this conductor. If the resistance of this conductor is more, then the amount of heat energy produced will also be more. Number 3, it depends upon time also. If the current is flowing for a long time, if 1 minute, probably 1000 joule heat energy produces, but in 2 minutes the amount of heat energy will be double, 2000 joule heat energy. That's why the energy produced due to the flow of current in a conductor or resistor depends upon 3 factors: current, resistance and time. Okay, after the understanding of this heating effect of current, now I want to tell you, or I want to introduce one metal called nichrome. In all the heating instrument, this metal, this is an alloy of nickel and chromium, is used in those heating instruments. What is it? This nichrome. If you are told to write about nichrome, or if you are told to say what is nichrome, then what can you say? What do you say? Nichrome is an alloy of nickel and chromium which has high resistance and is used in the heating instrument to convert electrical energy into heat energy. So many points are told in this definition or the this introduction of nichrome. It is an alloy. Alloy means mixture of metal. Which metals are used? Nickel and chromium. And second, its property is told. What? It has high resistance. And thirdly, its use is told. Where it is used? Heating instrument. And why it is used in heating instrument? To convert electrical energy into heat energy. Now I want to show this. Look at this is the coil of nichrome wire, and it is used in heater. The same is used here in heater, and it is used in this. This is so interesting. This is locally made room heater where nichrome wire is used, and here also nichrome wire. I think now you are clear that in many devices, many heating instruments, nichrome wire can be seen from outside. But there are some other heating instruments where we cannot see nichrome wire. But where is it inside this water heater? It is at the base. This is base plate of this water heater, and this base can be seen here very clearly. In this cylindrical part, this is hollow inside. There is nichrome wire inside this hollow space, and whenever current is passed through this nichrome wire, it becomes red hot and the base plate becomes hot, and it hits the water kept in this jug. Look at this another. This is another heating device. This is electric kettle. Here we have some structure. Look at this, is hollow inside, and inside this coil like structure there is nichrome wire, and when electric current passes through it, then nichrome wire becomes hot, and then it hits water kept in this container. Okay, this is electric iron, base plate of electric iron, and this part, inside this part, this nichrome wire is placed inside it, and when electric current is passed, it becomes hot and base plate becomes hot, and this base plate is used to press the cloth. Okay, now question comes, there are hundreds of metals, why nichrome? Why should we use nichrome only? Why should nichrome only selected? This is the question. Why nichrome? Now, I want to give answer of this question. There are certain reasons why we are using nichrome. Number one, it has high resistance. Why do we need high resistance? Because we want to convert electrical energy into heat energy to use for certain purpose. And high resistance wire is needed, otherwise electrical energy cannot be converted into heat energy. If a substance has high resistance and current is made to flow through this, then it becomes hot and then we will get heat energy. That's why nichrome has high resistance, so it is used. Next, it does not oxidize even in red hot condition. What it means? Almost all the metals, when becomes hot, it reacts with atmospheric oxygen and metallic oxide form. And because of this reason, if the metal used in this heating instrument oxidize, then what happens? Today a little metal is used up, tomorrow a little is used up. The coil has very thin wire, and if it is used up day by day, within few days it will break. That's why the metal which oxidize cannot be used in the heating instrument. But the nichrome, it resists oxidation. It doesn't oxidize. Even in red hot condition, its oxidation is negligible. So the nichrome wire is selected. Okay, next, it gives reasonable amount of heat energy because its temperature rises to about 900 degrees Celsius. What is the meaning of this saying? If a resistor becomes hot at the temperature of 500 degrees Celsius, then this becomes useless, because 500 degrees Celsius is not enough to cook food and to heat water. So it becomes 900 degrees Celsius, I mean to say it becomes red hot and yellow is hot. So it is used to it is it becomes red hot or yellow hot, and the temperature rises to 900 degrees Celsius. That's why this is the reasonable temperature which can be used in cooking purpose also and other purpose also, heating purpose also. That's why it is used. These are the points which we have to remember. Why nichrome? Its resistance is high. Why nichrome? Because it doesn't oxidize even in red hot condition. Why nichrome? Because it gives reasonable amount of heat at the temperature of 900 degrees Celsius. I think this is all about the heating effect of current for this class 9. Now I want to go to some other part, and this is electric power. You have heard about this. What is electric power? Now first, the definition. The rate of conversion of electrical energy into another form of energy by an appliance is called electric power of that appliance. You have done this mechanical power in lower classes. In mechanical power, what we studied in lower class, the rate of doing work is called in lower classes, what you have studied, the rate of work done, rate of doing work is called power. But here in electric power, rate of conversion of electrical energy into another form of energy by an appliance is called electric power of that appliance. Just for example, if we have 10 watt bulb, what it means? The power watt represents what? It means it converts 10 joule of electrical energy into light energy in every 1 second. What is the meaning of 1000 watt power of a heater? It means it converts 1000 joule electrical energy into heat energy in every 1 second. This is the meaning of electric power. Okay, it is represented by this formula. Electric power P equal to energy conversion upon time taken. Now, if we know what is electric power, then we must know what is 1 watt power also. 1 watt electric power means what? Power of an electrical appliance is said to be 1 watt if it converts 1 joule electrical energy into another form of energy in 1 second. If we have a device and it converts 1 joule electrical energy into other form of energy in 1 second, then its power is said to be 1 watt. And 1 watt equal to 1 joule per 1 second. Okay, how do we measure the power, electric power in the electric circuit? Using this formula. Very interesting, another formula came. P equal to I into V. P is power, electric power, I is current, V is potential difference or voltage. You know about this because in previous class current and potential difference was taught. Now how this equation came? I want to establish this equation. I want to derive this equation. Prove P equal to I into V. We are going to prove this. According to the definition of power, we know this, power is rate of doing work. Power equal to work by time. The mechanical power is work by time. I am taking this as first equation. And this, according to the definition of potential difference, do you remember what is potential difference? Work done between 2 points of a circuit by the flow of unit charge is called potential difference. And it was done, it was taught in previous class, and it can be represented by formula potential difference V equal to work done W by charge Q. And in this case, if we take the value W equal to V into Q, Q is if taken to left hand side, we have this equation. Now another, according to the definition of current, do you remember this definition of current? Rate of flow of charge is called current, which can be represented by this formula, current equal to charge by time. In this equation, if T is taken to left hand side, then we will get T equal to Q by I. Now third equation is established. Why I am doing so? Because I want to substitute this W by VQ, V into Q, and I want to substitute this T by Q by I. We can, because all the relations are correct. So we can say substituting the value of W and T from equation 2, W from equation 2 and T from equation 3 respectively in equation 1, then what we get? We'll get this P equal to V cube instead of W, and instead of T, Q by I. Q cancel, I goes up, and we proved P equal to I into V. This way electric power equal to current into voltage is proved. Now we proved one equation. Why don't we use this equation to solve the numerical problem? Let's go through numerical problem. Okay, look at this. What amount of electric current will be drawn by an electric iron of power 1000 watt when it is connected to household circuit? What will be its resistance? So this is very practical matter. If you are connecting a heater of 1000 watt in your household circuit, then what amount of current is drawn by this electric iron, and what is the value of resistance? Okay, let's solve this numerical problem. I am writing the given information. Power is given, P is equal to 1000 watt. Nothing is given now. What it is? How can we solve this? We have to know that in previous class also you are told that in a household circuit 220 volt is supplied. What it mean? For the flow of 1 coulomb charge, 220 joule energy circulates in a household circuit, and that's why we can write here potential difference V is equal to 220 volt. We know this. And what is the question? What amount of electric current? Current is asked, and another resistance is also asked. Now how to solve this? Very easy. We have P equal to I into V, and power is given here. Power is 1000 watt, and this is equal to I. We are going to calculate, and V, it is 220 volt. If we take this 220 volt to left hand side, then 1000 watt divided by 220 volt is equal to I. Now we have to divide 1000 by 220. Okay, I'm going to divide this by using calculator. 1000 is, if divided by 220, this is equal to 4.5454. It means 4.55. We can write 4.55. Therefore, I is equal to 4.55 ampere. When 1000 watt heater is connected in household circuit, then according to this calculation, it draws 4.55 ampere current. Okay, there is another question also. What will be its resistance? Now, how to get resistance? Using Ohm's law. According to Ohm's law, resistance is the constant and it is the ratio of V by I. We can use this equation and we can write again R equal to V by I, or R is equal to V is 220 volt and current 4.55 ampere. If we divide 220 volt, if we divide this 220 volt by 4.55 ampere, then what we get? This is equal to 48.3516, 48.35. Therefore, the resistance of that heater will be 48.35. 48.35 ohm. Unit of resistance is ohm. That's why I am writing ohm. This is the solution of the problem. Now, why should we go through only problem? Let's take a break with the question. With the question, which of the following equation is correct? Now, which equation is correct? We have to select the correct equation from these four. 1. V equal to P by I. 2. V equal to Q by W. V equal to I by R. And EMF equal to V minus V. Capital V minus small v. Now, which one is correct, or we can identify each of them. Which is correct, which is not correct. 1. V equal to P by I. If I is taken to left hand side, P equal to I into V is correct. P equal to I into V. First is correct. Now second, V equal to Q by W. Potential difference equal to work done by charge. It should be work done by charge, but here charge by work done. This is incorrect. Now 3. V equal to I by R. V equal to IR is the correct relation according to Ohm's law. V equal to IR. It should be, but here it is I by R. This is incorrect. EMF equal to capital V minus small v. Capital V represents total potential difference and small v represents the potential difference inside the cell. We can say this is external potential difference, this is internal potential difference. PD between positive and negative terminal of cell or battery is called external potential difference, but when the current flows inside the cell from negative terminal to positive terminal from the inner side, then certain amount of work is done inside the cell also, that is taken as internal potential difference. It was done in previous class, and external PD plus internal PD is equal to EMF, not subtraction. If we subtract internal PD with external PD, it will give EMF. If we add both of them, then that becomes EMF. The energy supplied by a source for the flow of one unit charge round the circuit connected to it is EMF, and this EMF is equal to external PD plus internal PD, not minus internal PD. So this is also incorrect. Only one is correct, other are incorrect. Now this part is also finished. Electric power, according to the syllabus of our class, this is enough. Now I want to go through measurement of electrical energy consumed in our household circuit. How do we measure? Measurement of electrical energy. Electrical energy is measured in joule, the unit joule. Not only electrical energy, the heat energy, light energy, sound energy, every form of energy is measured in joule according to SI system. According to SI system, energy is measured in joule. But in a household circuit, electrical energy consumed is not measured in joule. The reason is very genuine. I want to show you the reason with this mathematical expression. Look at this. Why we are not using joule to measure the electrical energy consumed in our house. The reason is, let's say we have a 10 watt CFL in the form of bulb. What it means? It converts 10 joule of electrical energy into light energy in every 1 second. In 1 minute into 60. In 1 hour into 60. And in a day, certainly we'll use it for 4 or 5 hours. Let's say we are using it for 5 hours daily. Then in 5 hours, this amount of energy will be consumed if it is measured in joule. If we multiply all these, then what we get? 6 6 are 36, and we have 30 into 5 again. 30 are there. 6 5 are 30. The 0 and 3 carry over. 5 3 are 15 and carry over 3. This is 1,80,000 joule. 1,80,000 joule electrical energy will be consumed by a CFL of power 10 watt in a day. In a month, it should be multiplied with 30. Not only a CFL bulb, there are many bulbs in a house. Not only bulb, your favorite TV is also there, and there is a refrigerator also. There are some other appliances also. If all of them consumes electrical energy and it is measured in joule, then what happens in a month? Probably we have to say this way, 55 crore 43 lakh 23,506 joule electrical energy is consumed in this month. This is so funny. It's a very big number. That's why electrical energy is not measured in joule. Joule is very small unit, and it cannot be used to measure electrical energy consumed in a household circuit. The distance from Kathmandu to Dharan cannot be measured in millimeter. It comes few lakh. Kathmandu to Pokhara cannot be measured in millimeter. It will be better to have kilometer, not even meter. So we are not using this joule. SI system now we are not using in this particular case. SI system is not used. What unit is used to find the electrical energy consumed in a house? The unit is kilowatt hour, and this is denoted by kWh, symbol kWh, kilowatt hour. Now what is 1 kilowatt hour? Look at this. The electrical energy consumed by an electrical appliance of 1 kilowatt power in 1 hour is called 1 kilowatt hour electrical energy. It means if we are using a heater of 1000 watt for 1 hour, then how much electrical energy it consumes? This is equal to 1 kilowatt hour. In daily life, we'll say 1 unit. The same is called 1 unit. And it is measured by using this equation, electrical energy equal to power into time. How do we measure this? The device, this device is used. I think you have seen this. This device is present in each and every house. Look at here. kWh is written. What it means? This electric meter measures the electricity consumed in your house in kilowatt hour. And the same we are saying unit. Okay. Now, how many joule makes 1 kilowatt hour? Let's talk about this. I want to go through mathematical expression. Look at this. 1 kilowatt hour. This is equal to 1 kilowatt into 1 hour, and this is equal to 1 kilowatt if converted to what? 1000 watt, and 1 hour means if multiplied by 60 minute, if multiplied by 60 comes in second, and this is equal to 1000 watt means joule per second, we know this, and this is equal to 60 into 60 second, second cancel, therefore 1 kilowatt hour is equal to 6 are 36, and there are 5 0 1 2 3 4 5. What it mean? This 1 kilowatt hour is equivalent with 36 lakh joule electrical energy. This is the understanding of the relation between kWh and the joule. Okay, let's go to another. Now I'm going to show you numerical problem, and I'm going to solve this numerical problem also related to electricity consumption in our household circuit and cost of electricity. Look at this. An immersion heater of 1500 watt is used to heat a bucket of water to take a bath. If it takes 20 minutes to heat the water, calculate the cost of heating of water at the rate of rupees 12 per unit. We want to take a bath in winter season, and that's why a bucket full of water is taken, let's say, and immersion heater is used to heat the bucket of water, and it took 20 minutes, and capacity, I mean to say power of electric heater is 1500 watt. Now what is the cost of heating of that single bucket of water? We are going to find out. Okay, what is given? Power is given. Power P is equal to 1500 watt is written, and bucket of water take a bath. If it takes 20 minutes, time is given 20 minutes. Very interesting. In other numerical problem, we were converting the unit into SI unit, but here we are converting SI unit into another. What is converted to, what should be converted to kilowatt, because we are using kilowatt hour. So 1500 divided by 1000 converts it into kilowatt, and this is equal to 1.5 kilowatt. Now 20 minute, we are not converting into second, we are converting minute into hour, because kilowatt hour is our unit. That's why 20 minute is equal to 20 divided by 60 converts it into hour, and 2 1s are 2, 2 3s are 6. This is equal to 1 by 3 hour. Now let's go forward. What is given? Rate. Rate is given rupees what? 12 per unit. Rate is rupees 12 per unit. Now we are using this formula, but before that, what is the question? Cost of heating. Cost is equal to what? We have electricity consumed is equal to power into time, and power is 1.5 kilowatt, and time is 1 by 3 hour, and this is 3 1s are 3, 3 5s are, you can use calculator. This is equal to what? 0.5 kWh. This is the consumption of electrical energy. I mean to say half unit. 0.5 kilowatt hour means 0.5 unit. Now we have to calculate the cost of electricity. Cost of 1 unit is equal to rupees 12. Therefore, cost of 0.5 unit is equal to rupees 12 into 0.5, and this is equal to rupees 6. Look at this answer. A bucket of water is heated and the cost of heating is 6 rupees. Okay, this is a small numerical problem. Just one device is used. Now I want to go through a big numerical problem. Look at this. A, B and C. Let's go through A, B and C. Consumption of tube light is equal to P into N into T. Instead of writing P into T, why N is also written? The simple reason is N represents the number of tube light, and 40 watt multiplied by 15 gives total power. That's why P into N gives the power, and this is at last power into time. That's why N doesn't make any difference. This represents the number of the instrument. Okay, when we take the value 40 watt into 15 into 5 hour, then the multiplication, after the multiplication we get 3000 watt hour, but we have to convert it into kilowatt hour. So dividing it with 1000 we will get 3 kilowatt hour. This is the consumption of one day. That's why consumption in 1 month is equal to 3 kilowatt hour into 30, and this is 90 kilowatt hour. Now this is the monthly consumption of tube light. Now let's talk about rice cooker, which is given in B. Consumption of rice cooker is again P into N into T. P 750 watt and 3 rice cooker, and time 1 hour. When we multiply all these, 2250 watt hour, and if we divide it by 1000, 2.25 kilowatt hour. Now in 1 month the consumption will be 67.5 kilowatt hour. Okay, now C. Consumption of iron is also P into N into T. The value of P is 1000 watt, N is 3, and time of use is 0.5 hour. When we multiply all this, 1500 watt, and this is equal to 1.5 kilowatt hour. This is the consumption in 1 week. We have to convert into 1 month. Then per month consumption of iron will be equal to 1.5 kilowatt hour into 4. Why multiplied with 4? Because we can say that 1 month contains 4 weeks in average. That's why the average value 4 is taken. 4 week makes 1 month. In that concept we get this answer 6 kilowatt hour. Okay, now we have to get the sum of all these consumption, 90 kilowatt hour and 67.5 kilowatt hour and 6 kilowatt hour. Per month total consumption equal to 90 plus 67.5 plus 6 kilowatt hour, and this is equal to 163.5 kilowatt hour, and kilowatt hour means unit, 163.5 unit, and cost of 1 unit is rupees 12 given. So cost of 163.5 unit is equal to rupees 12 into 163.5, it gives 1962. I mean to say rupees 1962 is the final answer. Okay, our time is finished. Today we did heating effect of current, and then electric power, and then electricity consumption in household circuit. I hope that this matter you can produce at another place also. Okay, in next class we'll meet with some other chapter, because electricity is finished from today onwards, and so we'll meet in another chapter. Thank you.